Hello, my dear friends. You are together with teacher Jerome MUTABAZI, a teacher of mathematics and physics. We are going to see another virtual experiment by using Colorado PHET simulations. I've told you that you can use these Colorado PHET simulations as an alternative way when you don't have well-equipped physical laboratories. So these virtual simulations has different topics in physics, mathematics, biology, chemistry, and of science. So now today's session, we are going to see how you can construct a direct current circuit with some appropriate components. Now, what you have to do, you have to go on Google and browse PHET, and then go to the simulation that you wish to observe. Now, we can go to PHET, and then here we do have the simulation regarding to the DC and AC circuit. Then let us open, and you have to go to RAB. Yeah. So here we do have different components, and you're going to pick one by one depending on the kind of the circuit that you are going to develop. So the main component I picked is battery. You cannot construct any circuit without power supply. So the battery, the main role of the battery is the power supply to supply the power in the electric circuit. Then here in the light box we do have at the top, we have to open the values, so it will show us the magnitude of the values of each component. Um, so this battery has 9.0 volt. We can pick another battery also. Can pick another battery. Now a battery, we do have the power supply of 18 volts. We can put another one. Now I do have 27 volts as the power supply. So then what you have to know, what you want, you have to connect the components in the circuit. We need the wire, the connecting wires. So you can pick the wire, so to connect other components. Yeah, can pick another wire. Yeah, and then we can just connect the switch. I think you know the role of the switch. The role of the switch, it is to close or to open circuit, to open or to close the circuit. Yeah, so after we can connect another wire. Can connect another wire here. Yeah, then you can connect a light bulb. Can connect a bulb. You know that this bulb or electric lamp, its main role is to convert electrical energy into light and heat energy. Yeah. Yeah, now we do have a complete circuit here. We do have a battery, we do have a connecting wire, we do have an electric lamp, and we have a switch. So you can switch on to see if our circuit, if the current can just circulate in our circuit. Yes, that is it. So now you can see in the light bulb or in the lamp, we do have the internal resistance of 10 ohms. 10 ohms. So that is it. We can now calculate the current that is flowing in the circuit according to the Ohm's law. You can calculate the current. As the Ohm's law states that the current crossing the circuit is directly proportional to the voltage in the circuit. And also is the current across the circuit is inversely proportional to the resistance. If the resistance increase in the circuit, the current will decrease at the same time. So if the resistance decrease in the circuit, the current will increase. So that is all about the statement of Ohm's law. So now we can calculate the current that flowing in the circuit. If the total voltage or the total potential difference in the circuit will be equal to 9 volt plus 9 volt plus 9 volt will be equal to 27 volts. So the current will be equal to voltage over resistance. Now current will be equal to 27 volts over 10 ohms. So the current will be equal to a 2.7 ampere. 2.7 ampere. That is the total current that is flowing in the circuit. And you can see in the switch we do have a zero resistance, so it hasn't any resistance in the circuit. The current flow the switch freely. So in order to demonstrate this one, you can connect a meter in our circuit to check if the current that is flowing in the circuit is equal to 2.7 ampere. Let us pick to the ammeter to check if the current that is flowing is 2.7 ampere. We can put what you have to know. The ammeter is always connected in series in the circuit. It is already connected in series in the circuit. So let us switch off our circuit and then connect ammeter here. Can you connect ammeter? Can you connect ammeter? Yeah, now let us switch on. Now you can see in our meter, the current that is flowing in the circuit is equal to 2.7 ampere. That is it. Through the calculation, the total current is equal to the voltage in the circuit over total resistance or equivalent resistance in the circuit. Yeah, that is it. Now we can just measure the voltage or the potential difference in the circuit. To measure the potential difference in the circuit, what you have to use the special device which is to measure potential difference, which is called the voltmeter. You can connect a voltmeter in the circuit. So now what you have to know, voltmeter is always connected in parallel to the component where you're going to measure the potential difference. So you can connect the voltmeter here, and you connect the voltmeter. So the voltmeter will show us the total potential difference or total voltage is equal to 27 volts. Let us see if the total potential difference in our circuit is 27 volts. Now you can see the total potential difference in our circuit is 27 volts. So it has to be connected in parallel to the components that you are going to measure the potential difference. Now we can connect another components here. We can connect another components here. Instead, according to the Ohm's law, as the resistance increases, the current will also decrease. So let us connect the resistor in the circuit. So this resistor has 10 ohms, as 10 ohms. So we can now switch off the switch, then let us connect the resistor here. Yeah, no problem. So the total resistance in the circuit is equal to now 20 resistor, the 20 resistance. That is the total resistance in the circuit. So if you calculate the current will be equal to voltage over total resistance will be equal to 27 volts over 20 ohm. So now let us see the current that will be shown by the ampere, the ammeter in the circuit. I can see the current is 1.35 ampere. So this means as the resistance increases in the circuit, the current will decrease. So the current is now 1.35. So what if we put another resistor in the circuit? Let us put another resistor of 10 ohms. Now you can see current is 0.90 ampere. As the resistance in the circuit increases, the current will decrease. So this is how the Ohm's law is just being demonstrated. So you can demonstrate this Ohm's law in front of your students by using Colorado PHET simulations. So we do have a different components here that we shall connect in the next simulations, but this is related to the direct current circuit. Next session we shall connect the alternating current source and see how we can measure different parameters. So thank you so much. You remember to subscribe on this YouTube channel. So we shall bring many simulations and show you how can demonstrate some experiments. This is a kind of hands-on activities that you can do in front of your students so that to make the lesson more understandable. So thank you so much. See you in the next session.